So continuing where we left off, we were looking at that plot for experiment 1 with the propane, and you will see something very similar. Now when you are doing this plot, you will be using the graphical function, and I think I mentioned that in we looked at it when we were discussing, or when I was discussing lab 3 about density, where the graph option, where plotting the graph was optional, but I showed you what the graphical function is in late night labs. So you will be doing your graphs using the graph function in late night labs, and it'll automatically attach your graphs or insert your graphs into your lab report. However, if you're having any kind of problems and you wish to do this in Excel, then either I'll make another separate video, or if time permits, I will continue after this. After I finish this PowerPoint, I will show you how to plot a straight line graph in Excel, and then you can you also have that additional option of plotting these graphs in Excel and then emailing those graphs to me separately if that's how you wish to do it. However, it's easier to just use the graph function in late night labs itself. Okay, and so this was the results for butane, and as you can see, it's quite similar to that of propane. And the plot also, when you now here I have it correctly, pressure versus 1 by volume, and again 75 ml, as I explained before, is around 0.013. So again, if you draw a line up and then draw another line to the y-axis, it falls at 2 atm, and then 300 ml is 0.003. So again, you draw a line, draw perpendicular to the plot, and then another line to the y-axis, and it corresponds with 0.5 atm. All right, so this is verifying the Boyles law, the plot, the straight line plot. So conclusions. So in both experiments, the results and the graphs are identical. So Boyles law states that the pressure and volume are inversely related, especially when temperature and number of moles are kept constant. So all ideal gases will behave exactly alike, and that's why the results and the data are identical. So what did you learn from this law and this experiment, and how does it apply in real life? Breathing is following Boyles law, right? That's Boyles law in action. When we breathe air or oxygen, it's because that diaphragm contracts, pulling down, increasing the lung capacity. Now when the lung capacity increases, that means the pressure inside the lungs will drop. So air from the outside will rush in so as to equalize the pressure inside and outside the body. And so then the diaphragm relaxes, the lung capacity decreases, and the pressure inside the lungs will increase, and so the bad air, which contains carbon dioxide, is forced out, so as the pressure inside and outside the body is equalized. So again, this happens all the time as we are breathing, and we may not even think about it, but this is a real life example of how Boyles law works. What are some other, and I didn't mean to do that, what are some other applications of Boyle's law, right? Again, you can research other applications of Boyle's law to see if you can find other things other than just breathing, and how it would be useful, especially in the world of medicine and nursing. All right, I talked about showing you exactly how to do a plot in Excel. So what you do is, now I took an example of the internet. So basically what you do is you start by typing in your data. So as it says here, you enter your data into an Excel spreadsheet. Then you make sure you highlight those cells containing the data. So that first column is usually the x-axis. So the data for the x-axis, which is the 1 by V, goes in here. And then the y-axis, which is all the pressure, the numbers for the pressure, goes into the second column, right? And then you highlight these cells containing the data. And once you do that, from the Insert tab, you click Charts and then Scatter. And you can have two types of scatter plots, but you're going to select Scatter with only markers, all right? So then your data will get plotted and you'll kind of see a straight line. However, the dots won't be connected. Now what you can then do is, once you have that, you can get into the Layout tab from the Chart Tools and then add a title, the chart title, and add the axis labels like pressure and 1 by volume. Not like me, I had them mislabeled. And then you can also go to Chart Tools back again from the Layout tab and click on Trend Line and select the Linear Trend Line option, right? And then you will see that you'll get the line, all right? Now, this is automatically done, I think, in late night labs when you do the plot. And then you'll be wondering, where's my line? It's just that because of the fact that it's virtual labs, and there won't be any difference between the trend line and your line, so they kind of merge together. And then if you do two of those gases, the two of the plots in one graph, then of course you'll only see one kind of line. So I get this question sometimes about why can't I see my plot, why can't I see my line? It's because they all got merged up together just because those numbers are almost identical. Okay. And then if you click on that trend line and select more trend line options, then you can even display that equation for the straight line. Okay. So in this equation, of course, y, which is the y-axis, and the slope in this case would be the constant. This number here is the slope. That would be the constant, because the equation for a straight line is y is equal to mx plus c, right? C is the intercept, m is the slope of the line, and m for us for Boyle's law would be the constant, the Boyle's law constant, all right? Intercept is when you drag the line like I did in my plot. When you drag this line up to 0, okay, what you will see is that that line cuts the y-axis at 0, all right? So that gives you the corresponding pressure at 0 volume. Okay, and that's it. You can also use the text box option to add in the slope and intercept values after you obtain your equation, all right, like I did here, all right. So again, this is pretty simple, and you can play around with it and make it as sophisticated as possible, if that's the correct word, or as detailed as possible, all right. Okay, and that's the end of this video and the end of the discussion on Boyle's law.